The change in diameter of a large steel bolt is carefully measured as the nut is tightened. Knowing that E is equal to 200 gigapascals and V is equal to 0.30, that's Poisson's ratio, it's a nu actually, determine the internal force in the bolt if the diameter is observed to decrease by 13 micrometers, which is meters times 10 to the negative 6. All right, so we have Poisson's ratio, and we know that there is stress applied in this direction, but that's going to cause a compression here, and some sort of force is developing inside that member as well. So as long as we're in the elastic region, we can find the stress in a plane with the generalized formula for Hooke's law. So what I'm going to do is I'm first going to find the deformation. Well, they told us the deformation is decreased by 13. So the deformation delta is going to be minus 13. I'm going to say minus 13 times 10 to the negative 3 millimeters. Now the original length of this y direction, that original length was 60 millimeters. So I can find the strain in that direction. It's going to be negative 13 times 10 to the negative 3 millimeters divided by 60 millimeters. And what is that going to give me? All right, so negative 13 times 10 to the negative 3 divided by 60. That's going to give me minus 2.167 times 10 to the negative 4 millimeters over millimeters. Now, we use Poisson's ratio. We recognize that the load is originally applied in the x direction. So we'll say that Poisson's ratio is equal to the negative of the strain lateral. Let me write that better. The strain lateral over the strain longitudinal. And so the longitudinal is over which the force is applied. And in this case, it's along the x-axis. So this is going to be epsilon x. This is going to be epsilon y. All right. So now we have epsilon y. We have nu. We can solve for epsilon x. Is going to be epsilon y divided by nu, which is going to be what? It's going to be negative 2.167 times 10 to the negative 4 divided by 0.3. And what is that going to give me? It's going to give me minus, and there's going to be a negative in front because that's the formula. I forgot to put it in. So this is going to be negative. This is going to be a positive 7.22 times 10 to the negative 4 millimeters over millimeters. Now, they want to know the internal force. So what I do is I know that Sx is P over A. So we can say that P is Sx times A. So let's find our A real quick. That's going to be pi times the radius, which is 0.03 meters squared. So pi times 0.03 squared, so that's going to give me 2.827 times 10 to the negative 3 meters squared. Once we do that, all we need to find is sigma x. And we can use the generalized formula of Hooke's law, which uses the superposition principle, to say that E over 1 minus Poisson's ratio squared, I'm just reading the x line, times epsilon x plus v plus nu epsilon y. And there's nothing in the z. So this is going to be 200 gigapascals 1 minus 0.3 squared times 7.22 times 10 to the negative 4 plus 0.3 times minus 2.167 times 10 to the negative 4. We close all of that. And so what is that going to be? So 200 divided by 1 minus 0.3 squared multiplied by 7.22 times 10 to the negative 4 plus 0.3 times minus 2.167 times 10 to the negative 4. Put all of that in, and it's going to be 144.4 megapascals. And once I do that, I know my P is going to be sigma, not 6, sigma x times A, so 144.4 megapascals multiplied by my area, which is 2.827 times 10 to the negative 3 meters squared. So I'm going to take that, and I'm going to multiply by my area, and what I get as a result is 408. Remember, that was megapascals, so that's 408. I got to think about, because here I have 10 to the negative 4, but if I multiply by 6, it's going to be 408. And is that it, or is there more to that? Is that it, or is there more to that? I got kilonewtons before, so I need to get kilonewtons. And so, yep, that makes sense. Kilonewtons, because I did not convert it into my calculator. So this is my final answer. I hope this was useful for you. It definitely was for me. And I'll see you next time.